Okay, next up, we have strontium hydroxide that is a strong base and completely dissociates into ions in water. We would like to calculate the pOH of 5.9 by 10 to the negative 4 molar of strontium hydroxide and the concentration of hydroxides in a strontium hydroxide solution with a pH of 12.77. And so let's go ahead and write out the dissociation equation. So it completely dissociates into 2 plus 2 OH minus. Let's not forget our state symbols. An aqueous solution, and then using this we're gonna develop an ice table. And so because of the fact that we know that it's going into completion, if we just put in what we have, okay, so initially we have 5.9 by 10 to the negative 4, as we were told, 0 and 0 molar, and then because it's going to completion, it is going to lose 5.9 by 10 to the negative 4. This is, so the ratios we have here is 1 to 1 to 2, so it's going to produce 1 times this of strontium ions, so this is going to be plus 5.9 by 10 to the negative 4. And twice that for the hydroxide ions, so it's going to be plus 2 by 5.9 10 to the negative 4, and so this is going to be left with 0 at equilibrium. This is going to be left with 5.9 times 10 to the negative 4 molar at equilibrium, and this is going to be left with 1.18 by 10 to the negative 3. And then let me just ensure that that is correct. Okay, and so we know that the concentration of hydroxide ions at equilibrium is going to be 1.18 by 10 to the negative 4 molar. We also know that pOH is going to be the negative logarithm of this. So let's go ahead and calculate pOH. The reasoning for this is because we're trying to find the pOH. In the scenario where we're trying to find the pH, we just need to note that pH plus pOH is equal to 14. So the pH would be equal to 14 minus pOH. In this scenario, we're just going to stop at calculating pOH. Let's go ahead and take the negative logarithm of what we have, 1.18 by 10 to the negative 3 molar. And that is going to give us an answer of 2.93. If you plug that into your calculator, and that will be your final answer. In the scenario where they had asked for the pH of the solution rather than the pOH, you just do 14 minus 2.93, and that is going to give you your pH of 11.07. They typically would ask for the pH because that is what we're more used to finding in the lab than the pOH. Okay, for our next question, we want to find the concentration of hydroxide ions in a strontium hydroxide solution with a pH of 12.77. So we're going to be making use of the same equation. So first off, we know that, as stated before, pOH is equal to the negative logarithm of OH. But in this scenario, we're trying to find the concentration. And so we just note that we're isolating this. And so in order to go about that, the equation would become that the concentration of OH ions is equal to 10 to the power of the negative POH. And so we're given the pH, which is equal to 14 minus the POH. So in order to get the POH, we are going to do 14 minus the pH. So let's go about that. 14 minus 12.77, which would give you a POH of 1.23 would be a POH. And so to get the concentration of hydroxide ions, it's going to be 10 to the power of negative 1.23. And that is going to give us a final answer of 0.0589 molar, and that's going to be our final answer.